So we continue with this problem. This is the slushy fruit stand, and it states the slushy fruit stand makes two varieties of fruit drink. Each serving of Coral Splash contains 10 ounces of pineapple juice, 1 ounce of mango juice, and 3 ounces of watermelon juice, and sells for $5. Each serving of Cool Express contains 10 ounces of pineapple juice, 2 ounces of mango juice, and 2 ounces of watermelon juice, and sells for $6.50. Each week, Slushy Fruit Stand receives a shipment of 900 ounces of pineapple juice, 140 ounces of mango juice, and 240 ounces of watermelon juice. Determine the optimal solution of how many servings of each fruit drink the Slushy Fruit Stand should make per week to maximize its profit. So again, the first thing we're going to do is we're going to establish the objective function. Now, they're looking to maximize its profit. The Slushy Fruit Stand wants to maximize its profit. So we're going to use P for profit. And of course, the profit is going to be dependent upon how many Coral Splash fruit drinks they make and Cool Express. And the Coral Splash, that's $5 a drink. So then we could say that this is going to, if we let X be the Coral Splash, we can say this is 5X. And then over here for the Cool Express, they sell for $6.50. So if we let Cool Express be Y, then we can say plus 6.5Y. So this is our objective function. This is what we're trying to establish. What is that profit related to this problem? Now, the first step that we want to do now that we have our objective function is build a table so that we can collect our thoughts on this. And of course, we can see right here how many servings of each fruit drink. So that's going to be our variable. That's our unknown. And of course, the fruit drinks are the Coral Splash up here and the Cool Express over here. So these are our variables. And we know with our variables, they're going to be listed across the top of our table. Then, of course, for the rows are the elements that interact with the variables here. And those are going to be the pineapple juice right here, the mango juice, and the watermelon juice. Also remember that within our rows are the totals. So we could see right here, 900 ounces of the pineapple juice, 140 ounces of the mango juice, and 240 ounces of the watermelon juice. So now that we have all our elements together, our table is going to look something like this. So here we have our variables across the top up here. If we let Coral Splash be the X variable and Cool Express be the Y variable, and you create these two columns, we just happen to label the totals over here. Also in here is we have our objective function, the profit. And we do that because we want to see the relationship between the cost of the Coral Splash of X and the Cool Express of Y right here. But this would be our system right here. So we'll write that down. We have 10X plus 10Y. That's equal to 900. Again, X is the Coral Splash and Y is the Cool Express. X plus 2Y. That's equal to 140. And then 3X plus 2Y, that's equal to 240. And then we'll close off our system. So now that we created our table to help build our system, the next step is then we're going to graph the system. Now again, the graph doesn't have to be anything fancy, anything extremely accurate, but it should give an idea and it should represent what's occurring here with this programming problem. So I have this graph like this. Here is the line right here. That is 3x plus 2y is equal to 240. This line here is the 10x plus 10y is equal to 900. And then, of course, this line right here, that's x plus 2y is equal to 140. Now, we have to keep in mind that these lines are going to form boundary lines because as we can see right here, 900 ounces, we can't have less than that. The 900 is the maximum. Same way with the 140 and the same way with the 240. So we're going to change this linear system here into a linear system of inequalities. So we'll just write 10x plus 10y, and that's got to be less than or equal to the 900 ounces of the pineapple juice. Then we have x plus 2y. That's got to be less than or equal to the 140 ounces of the mango juice. We can't go over that. And then we have 3x plus 2y. That's got to be less than or equal to the 240 ounces of the watermelon juice. We can't go over that. Then we'll put in two other inequalities here. We'll have x is greater than or equal to 0, and y is greater than or equal to 0. And the reason we do that is, don't forget that the Coral Splash and the Cool Express, Coral Splash is x and Cool Express is y. We can't have less than 0 Cool Expresses or Coral Splashes. So we have to make sure that we note that in our constraints. And that's exactly what the system of inequalities is. And I'm just going to write it in right here. So don't forget, every linear programming problem is going to have an objective function, and that's this right here, and a series of constraints, a series of conditions or limits that put limits on our objective function here. So now that we've done this, the regions are going to fill in, and where all those regions overlap is going to be right in this area here. So it's going to make this geometric shape, and that geometric shape is going to be bounded by these coordinates here. One here, 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 got one here, and then one last one right here. And then in here, this is the feasible set. And again, the feasible set is all the set of solutions that will satisfy this system here of inequalities. But we don't want any coordinate that's in here. We want the one that's going to provide the maximum profit. So that's going to occur at one of these vertices here. So these are the vertices that we're going to check out. So this vertex right here, that's the origin. So I'm just going to label this. That's 0, 0. This one up here, this line here is x plus 2y is equal to 140. It's going through the y-axis. So it's going to have an x-intercept at 0. So we set x to 0 and solve for y. So this is going to occur at 0 and 70. This one down here, this is the line 3x plus 2y is equal to 240. It crosses the x-axis here. It crosses the x-axis or intercepts the x-axis. That's when y is equal to 0. So if we set y is equal to 0 and solve for x, this is going to occur at 80 and 0. So the only other two coordinates that we need to worry about is this one and this one. So we're going to solve for where those intersections are of the lines. So this line here, this is x plus 2y is equal to 140. So I'm going to write that in slope-intercept form. That's going to be y is equal to negative 1/2 x plus 70. And that intersects right here with 10x plus 10y is equal to 900. 10x plus 10y, that's equal to 900. We'll write this in slope-intercept form. That's going to be y is equal to negative x plus 90. So now we make these two equations equal to each other and solve for x, and then use that value to determine y. So we'll do negative 1/2 x plus 70. That's going to be equal to negative x plus 90. We could add x to either side and subtract 70 from either side. So this will give us x minus 1/2 x, and it's going to be equal to 90 minus 70. X minus 1/2 x, that's 1/2 x. 90 minus 70 is 20. X has got to be 40. Take this 40 and slug it into either one of these. If we slug it in right here, negative 40 plus 90, then y is equal to 50. So this coordinate right here is 40 and 50. Now we'll do the same thing for this coordinate here. So again, we have this line right here. And this line again is 10x plus 10y is equal to 900. 10x plus 10y, it's equal to 900. We write it in slope-intercept form. Y is equal to negative x plus 90. And that intercepts this line right here. And that's 3x plus 2y, that's equal to 240. We write this in the slope-intercept form, and that's y is equal to negative 3/2 x plus 120. We then make these two equal to each other and solve for x, then use that x to determine y. So we'll take negative x plus 90. That's going to be equal to negative 3/2 x plus 120. Add 3/2 x to either side. Subtract 90 from either side. 3/2 x minus x. That's going to be 120 minus 90. 3/2 x minus x. That's 1/2 x. 120 minus 90 is 30. X has got to be 60. We then take this value, we can plug it in right here. Negative 60 plus 90 is 30. So the coordinate for right here is 60 and 30. So now that we have our graph and all our coordinates, the third step is now we got to check each one of these coordinates and determine which one gives us the maximum or the most optimal output. So then P is equal to, then we'll take 5. That's the price of the coral splash. There's no need to go ahead and use the origin here, 0 and 0. That would be 5 times 0 plus 6.5 times 0. That gives a profit of 0. And that certainly doesn't make sense. So we'll do this coordinate up here, 5 times 0 plus 6.5. Of course, that's the price of the Cool Express, times 70. 6.5 times 70. And since we're talking about money here, that's $455. We'll try this coordinate here. It's going to be 5 times 40 plus 6.5 times 50. 5 times 40 is 200. 6.5 times 50 is 325 for a total of $525. We'll try this coordinate down here. 5 times 60 plus 6.5 times 30. 5 times 60 is 300. 6.5 times 30 is 195. So we have a total of $495. And finally, we'll try this one down here. So that's going to be 5 times 80 plus 6.5 times 0. 5 times 80, that's $400. So we can see that it's this value right here that will give us the maximum profit of $525. Where does that occur? That's when X is 40 and X is the Coral Splash and Y is 50. And of course, Y is the Cool Express. So how many servings of each fruit drink the Slushy Fruit Stand should make? Well, they should make 40 servings of Coral Splash, and they should make 50 servings of Cool Express, and they'll get a maximum profit of $525. And there we go.